In this tutorial, we're going to look at how to handle missing data. That means pre-processing your dataset in order to get it ready for running a machine learning model or doing other analyses. Before we start coding, let's cover some theory. First of all, you might wonder why you need to care about missing data. And the short answer is that if you don't know some of the values in your dataset, you can't calculate summary statistics and you can't run most machine learning models. Now, there are an almost infinite number of reasons why data could be missing. For example, if you have survey data, then maybe someone declined to answer a question. If you're looking at website click data, then maybe some users installed privacy tools, so you couldn't track them. If you have sensor data, then maybe a sensor wasn't working, or maybe a signal was too small to detect. Now, the point is that you need to understand how your data was collected and what missing values might mean in order to decide how to best deal with it. In terms of handling missing data, you essentially only have two choices. So you can either just ignore it, that is, anytime you have a missing value in a row of your data set, you just drop that row. Or you can try and make up values wherever you have any kind of missing value. And rather than just guessing or using a random number, we're going to put a bit of science behind it. And the art of sort of guessing reasonable values is called imputation. Now, there are basically 5 steps for handling missing data. And the first one is to standardize how the missing values are recorded. And after that, you can quantify how much missing data you have. And this is going to help you determine what strategy you're going to use for dealing with the missing data. And thirdly, as mentioned before, you can either delete the missing data or you can make values up, that is, impute the missing values. Fourthly, you're ready to run your model or do whatever other analysis you want. And finally, you want to be able to check what effect those imputed values had on your model. So in this tutorial, we're going to cover the first 3 steps. Now, because handling missing data is essentially a data manipulation technique, you can use pandas. We're going to do some of that here. Also, any good machine learning framework is going to have tools for imputation. So we're going to use scikit-learn in this case. You can also use PyCaret. And it's worth noting that there are a few other sort of niche Python packages available for doing specific tasks with the missing data. Just to manage your expectations, time series aren't going to be covered here. So when you have time series data, observations at nearby time points are going to be related. That means that time series basically have their own set of special methods for dealing with missing data. Likewise, if your values are missing because they exceed some kind of threshold, you are doing survival analysis, and that's a whole separate set of techniques. Also worth noting, we're not going to get into multiple imputation here, so that's a sort of more sophisticated technique, and it allows you to estimate the uncertainty in your model due to the imputed values that you've used. So we're not going to get into that here. And finally, it's worth noting that there are different categories of missing data. So there's one called missing not at random, and that means that there's some sort of pattern to the missingness, and that's caused by variables that aren't included in the data set. So that means that imputation may not be valid. I'll get into that in a little bit when we see the data set. All right, so let's try a case study. We're going to look at a data set on mammalian sleep durations. So this Msleep data set has been around a while. It's fairly popular. I believe the data set was originally formed from both a scientific paper and Wikipedia, so varying levels of trustworthiness there. It was popularized by R's ggplot2 package, and in Python is available via plot9. So the data set's a data frame, so we're going to start by importing pandas. We're going to import pandas as PD, and then from plot9.data, we're going to import Msleep. Now, I've added a little bit of extra code in order to demonstrate how we go about standardizing missing values. So I'm not going to explain this code, but let's just run it and you can see the data set. So here we have 83 different rows. Each row corresponds to a species of mammal, and you can see as we've got name, what they're eating there, whether a carnivore or herbivore or other things. We've got the IUCN conservation status, some metrics about how much they sleep each day, brain weight, body weight. So you can see we've got some missing values in some of these columns. And the point I made about missing not at random, that would be something like if the sleep cycle was affected by something that wasn't in the data set. So for example, it might be the location of the species. So if they live in a jungle, then we might know less about their sleep cycle, so it's more likely to be missing. So in that sort of case, you have to think carefully about what the question is that you're answering with your data and whether you think these unregistered sort of variables are going to have some sort of effect that might bias how things are missing. All right, so a couple of things to note. If we look at the conservation column, you can see that the missing values are recorded as unknowns. That's a non-standard way of recording a missing value. Likewise, in the sleep REM columns, this is how much the animal dreams per day. Missing values are recorded as with this numeric code of -999. So you see, if we try and take a mean of this column, it's going to be complete nonsense. So the first thing we have to do is deal with the non-standard missing values in these two columns. So in terms of standardizing missing values, it means converting these strings like unknown to a true NA, or numeric codes like -999 to a true NA. And by true NA, in this case, I mean NumPy's not a number, NaN value. So Pandas also has this special value for recording missing data, which it calls NA. Unfortunately, NA is not sort of widely supported even through all of Pandas's different methods, never mind by other packages. So it's a little bit safer to use this NumPy NaN value, at least for now. So we're going to import the NaN value from NumPy. So from NumPy, we're going to import NaN, run that. And then to standardize the missing values, we're going to use the replace method. So we're going to get a new variable called Msleep, and we're going to start with Msleep dirty, and we're going to call the replace method. Now this takes two variables. So the first one is a dictionary, and the keys to the dictionary are the columns where we want to replace values. So not conversation, conservation, and the value we're going to replace from this column is unknown. And then in the sleep REM column, we are going to replace the value -999. And then the value we're going to replace these with is nan. Okay, let's space that. So let's run this, and we're going to print it out as well. So run this cell. And you can see now, if we scroll over a little bit, so in this conservation column where it said unknown before, it now says null, and same where in sleep REM where it said -999, it now says null. Now, important thing to note is depending on which Jupyter Notebook editor you're using, this will sometimes be displayed as null, sometimes be displayed as NaN with usually with capital N's. So it means the same thing, it's just a different display. All right, so now we have standardized missing values. We can quantify these. So we're going to use two different Pandas methods. So the first one is NA. That returns a true or false depending on whether a value is missing, and then mean, because if you take the mean of true and false values, you're going to get the proportion of true values. So all we can do is start with Msleep, and we call is NA, and we're going to chain it together with mean, run that. So here a value of 0 means no missing data, so you can see all the names are present. In the vor column, you can see it's pretty low number, so 0.08, so that means 8% of the data values are missing in that column. With sleep cycle, it's much higher, 61% of values are missing. And if we had a value of 1, then that would mean all the data was missing in that column. So, as mentioned before, the easiest thing you can do with missing data is just to get rid of it. So if we do msleep, I'm going to call the dropNA method, and that's going to get rid of any rows where there's at least one missing value, and let's see what happens. So same columns, but now you see we only have 12 rows instead of 83. So even with sort of fairly moderate levels of missing data, this has been pretty disastrous. So we've lost most of our data set, and that's really not ideal. So the important takeaway is that dropping data is only going to be a suitable solution if you only have a very small amount of missing data. So in general, you're going to have to do imputation rather than just ignoring the missing data. Now, in scikit-learn, the way you have to deal with missing data in numeric columns is different to the way you have to deal with missing data in unordered categorical columns. So we're going to have to split the data set in two. Now, for ordered categorical data, like you see in the conservation column, where it goes from, let me see, so something like least concern through to, I think it goes all the way down to extinct. So there's a sort of series of different categories. But so for this kind of ordered categorical data, you can either treat it the same way as you would treat the unordered categorical data, or you can do a trick where you use ordinal encoder, turn those ordered categories into integers, and to pretend that it's a numeric column. So for simplicity, we're going to take the former approach. Whichever approach you assume, there's a lot of subtlety in terms of deciding which one you're going to do. It really depends on what problem you're trying to solve and what you believe about these ordered categorical columns. But we're going to do the simple thing and treat all the categorical data the same way. So next step, split the data set into two columns by type. So we're going to use the select dtypes method for this. So we're going to have msleep, we'll call it num for numeric. So we're going to start with msleep, and we're going to do select dtypes, and we're going to get the float columns. So float as in floating point numbers, and let's get this printed. So you can see in this case we've got 6 columns now. And let's do the same with the categorical variables. So we're going to do msleep dot select dtypes, and this time we've got 2 options. So object means it's a text column, and then category means it's a categorical column. Let's just copy and paste this so we can print it out. And here you see we've got the other 5 columns. All right, so the simplest form of imputation, so this is for numeric columns. It's a pretty stupid approach, but it's sort of okay in some cases. So what you do is you take the mean of the known values in that column, and then you use that value for the missing values. So we've got 2 options here. Scikit-learn has a thing called simple imputer, and in Pandas it's called fillNA. We're going to focus on simple imputer because it makes it easiest to sort of transition to the other imputer types that we're going to use later. But I think fillNA sort of explains what's going on a bit more clearly. So we're going to use that to check our working. All right, so first thing is we need the impute submodule of scikit-learn. So we're going to do import sklearn.impute and give that an alias, let's call it SI. And then we're going to create a simple imputer object. So do si.simpleImputer, run that. And the way we do this imputation is we call a fit transform method. So the fitting part just means calculating the means of the columns, and then transforming means replacing the missing values with those means. So we're going to do 2 steps in one go with this method. All right, so let's try that now. So we're going to do simp, and then we're going to call fit transform. I'm going to pass it msleep numeric. So if we run this, you see, slightly annoyingly, scikit-learn only really cares about numpy arrays, so it's given us a numpy array here, but that's annoying to work with. So we're going to convert it back to a data frame. So we're going to use pd.dataframe, pass that in, and then we need to steal the column names from the Msleep data frame. Okay, what's the error here? Ooh, this should say dot columns. All right. Okay, so we've got a data frame again, and here you see, like in the previous data set, the first 3 values of sleep cycle were all missing, and now you can see they've all got this value 0.44-ish. So that's the mean of this column, the known values in this column, and it's just dumped this mean in all the missing values. So same with the brain weight, the mean of this column is 0.28, and it's put that in all the missing cases. All right, so let's try this again with pandas, and you can really see how this works. So the first thing we're going to do is calculate the mean of each column. So we're going to have a variable called, let's call it column means, and so we're going to start with Msleep numeric, and we're going to call mean. And then, so that's the fit step, and then the transform step is going to be replacing the missing values with those means. So we're going to start with Msleep numeric, and we're going to call fill NA in order to replace the missing values, and we're going to fill it with this column means variable. So that's the transform step. So here you can see we've got exactly the same situation. So it's this like 0.44 value in the sleep cycles, 0.28 in the brain weights. So we've got the same answer twice. So that means I'm hoping our code is correct. And there is a caveat to this, because that's a kind of pretty stupid approach, just putting the mean in there. It means it's only really appropriate to do this when you have a small amount of missing data, just like when you drop data. I have heard anecdotally that this method performs better when you have lots of features. So we're talking like hundreds or thousands or maybe even more features, because that means that the effect of any individual feature is pretty small. I've not tried this myself, though. I've not seen any sort of quantitative research on like how much better it gets, but that's the sort of heuristic I've heard, that this only makes sense when you have lots and lots of features. All right, so that was the case for numeric columns. So now let's take a look at categorical columns. So if you've got categories, then the mean doesn't make sense. So one thing we can do is use the mode instead. And so that means we're looking at the most frequent value in each column. So we're going to create another simple imputer. So we're going to call this one simpmf for most frequent. So we're doing si.simple imputer. And this time we're going to set the strategy argument to most frequent. So it's going to put the mode in this time. All right, so now same situation as before. We've got this simple imputer object, and we're going to call fit transform, if I can type this properly. No, I can't. Okay, and we're going to pass in this time the Msleep categorical values. You see, again, it's returning a NumPy array, so we're going to do that conversion to pd.dataframe. And we're going to borrow the columns from Msleep categorical. Columns, plural. Okay, so this time, so for example, with the bore column, the most common value before was herbivore. So it's filled in, wherever we have a missing value, it's filled in the value Herbie. Now, again, this isn't really like a perfect approach, but it's the best you can really get using scikit-learn. So this is the sort of the standard approach that gets used. Now, a more sophisticated option is to use a different imputer called Iterative imputer. So again, this is just for numeric columns, but what this does is it fits a predictive model. In this, by default, it's a Bayesian ridge regression, but you can change the model type. So it fits it one column at a time, using the other columns to try and predict that column. And basically, by repeating this process several times, you get more and more missing data filled in, and you get better and better predictions, and eventually, like, it fills in all the missing values. So because this is more sophisticated, it should probably be your starting point for doing most imputation with scikit-learn. But one thing to note is that as of version 1.0.2, which is what I'm using here, it is considered experimental, so you need to enable it before using it. So to enable it, we're going to start with sklearn.experimental, and we're going to import a thing called enable iterative imputer. Have I spelled that right? No, I'll go with the. Okay, and then we can create our imputer object. So in this case, we're doing si.iterative imputer, and then just as before, we call the fit transform method. I'm going to pass it msleep numeric, and then again, it's going to give us a numpy array back, so we're going to have to do that conversion back to data frame, and we're going to get the columns from msleep numeric columns. All right, so looking at the results this time, you can see here that whereas before, with the sleep cycle column, those first three missing values, it was replaced with like 0.44, exactly the same value each time. This time, it's given us a slightly different value. So based on the results of the other columns, it's predicting that the missing value is going to be slightly different in each case here. So this often gives you better performance. All right, so that's so now we've filled in all the sort of missing values. We're ready to run a model. So that's the end of this tutorial. Imputation is such a big, complex topic that there is so much more to learn. So DataCamp, in fact, has at least 3 courses on this topic. So I would start with dealing with missing data in Python, but there's also information about handling missing values and cleaning data in Python, and machine learning with scikit-learn. Pandas has its own tutorial on working with missing data. So does scikit-learn. It's got a tutorial on imputation. So there's lots more to learn here, but I hope this is enough to help you get started handling your missing data. Thanks.